Now let's take up questions from exercise 14 of the second book. Question number 1, it says, find the value of k if the distance between the points 1, 4 and k1 is 5. Now the distance formula is equal to, distance is equal to x1 minus x2 whole square plus y1 minus y2 whole square and the square root of the whole thing. Alright, so distance given is 5, x1 is 1 minus x2 is k. So 1 minus k whole square plus y1 is 4, y2 is 1. So 4 minus 1 whole square and the square root. Now if you take square on both sides, it becomes 5 square on the left hand side and the right hand side square root goes away. Now 1 minus k whole square is equal to plus 4 minus 1 is 3, 3 whole square is 9. So it is 25 equal to 1 minus k whole square plus 9. 9 goes to the other side, becomes 16 is equal to 1 minus k whole square. Now here, if you take the square root, it will be plus minus 4 equal to 1 minus k, right? So it will be 4 equal to 1 minus k and minus 4 equal to 1 minus k. So from the first one you get k equal to 1 minus 4, that is minus 3, and from the second one you get k equal to 1 plus 4, that is 5. So there are two possible values of k, minus 3 and 5. Okay, so the answer is B option. Alright, now let's take second question. It says the points whose coordinates are 2, 2, 6, 3 and 4, 11 forms, and the options has different types of triangles. So what we do is, let's say the point A is 2, 2, or let me put it in this manner. So A is 2, 2, B is 6, 3 and C is 4, 11. So let's calculate the lengths of the sides of this triangle. So we have AB length, and that will be equal to square root of x1 minus x2, that is 2 minus 6 whole square, plus y1 minus y2, that is 2 minus 3 whole square. So we have 2 minus 6 is minus 4, minus 4 square is plus 16, so square root of 16, plus 2 minus 3 is minus 1, minus 1 square is 1, so it is equal to root of 17. Similarly, if you calculate AC, it will be equal to square root of x1 minus x2, that is 2 minus 4 whole square for A and C, and y1 minus y2, that is 2 minus 11, so 2 minus 11 whole square. Now 2 minus 4 is 2, minus 2, minus 2 square is plus 4, 2 minus 11 is minus 9, square is 81, so 81 plus 4 is 85, so it is root of 85. Then let's calculate BC. BC is equal to square root of 6, and x1 minus x2 will be 6 minus 4. So for B and C, x1 is 6, x2 is 4. So 6 minus 4 whole square plus 3 minus 11. y1 minus y2 will be 3 minus 11 whole square. Now 6 minus 4 is 2. 2 square is 4. 3 minus 11 is minus 8. Square is 64. So it comes out to be root of 68. Alright. So that means no two sides are equal. So it cannot be an isosceles triangle. It cannot be an equilateral triangle. Now the other two options are scalene triangle and right angle triangle. Right. So it is a scalene triangle. Yes, it is a scalene triangle. But there is one more thing. Let's check for right angle triangle. What should be the situation? The smaller sides here are AB and BC. So let's check AB square plus BC square. For right angle triangle, the squares of sum of squares of the smaller side should be equal to the square of the third side. Now AB square would be root 17 square and BC square would be root 68 square. So it becomes 17 plus 68, that is equal to 85. Right? Now 85 is square of root 85, so it is equal to AC square. So we have AB square plus BC square is equal to AC square. Right? So the answer here is the triangle is a right angle triangle as well as it is an isosceles, scalene triangle. So answer is both B and C. Right? Be careful, it is both B and C. Right? So the answer is both options B as well as C. Options B and C both are correct because they say right angle triangle as well as scalene triangle. For scalene, no side should be equal, right? For right angle triangle, the sum of squares of two sides, two smaller sides, should be equal to the square of the largest side. Okay. Now let's take up the third question. The third question says the following points A, B, C, D taken in order form, and the options are rectangle, parallelogram and square. Let me put it like this. If there are 4 points like this, we don't know what it is. We don't know what is the structure. Let's say A is -1, 0, B is 3, 1, C is 2, 2 and D is -2, 1. Okay. Alright, now how do we check whether it is a rectangle or a parallelogram or a square? First of all, what we need to do is check the midpoint of diagonals, right? Check the midpoint of diagonals, right? Let's say the midpoint of first diagonal AC is M, and let's check the midpoint of AC. Let's check the midpoint of AC. Midpoint of AC would be, so A and C, so it will be x1 plus x2 by 2, that is -1 plus 2 by 2, and 0 plus 2 by 2, right? y1 plus y2 by 2 is 0 plus 2 by 2. So it is 2 minus 1, 1 by 2, and 2 by 2 it is 1. So 1 by 2 and 1. These are the coordinates of midpoints of AC. Similarly, check the midpoint of BD. That is equal to x1 plus x2, that is 3 minus 2 by 2, and y1 plus y2, that is 1 plus 1 by 2. This also comes out to be 1 by 2 and 1, right? So the midpoints of diagonals are same. That means diagonals are bisecting each other. That means it is a parallelogram, right? So to check whether a given quadrilateral is a parallelogram or not, what we need to do is check whether the midpoints of the diagonals are same or not. Now it is a parallelogram. Now further, rectangle and squares are nothing but parallelograms. Now for rectangle and square, we need to check the length of sides. If all the sides are equal, then it is a square. If only opposite sides are equal, then it is only a rectangle. So now let's check the lengths of the sides. So let's say AB. AB would be equal to square root of x1 minus x2, that is -1 minus 3 whole square, plus y1 minus y2, that is 0 minus 1 whole square. So this comes out to be -1 minus 3 is -4, square is 16, and 0 minus 1 is -1, square is 1, so it is root 17. Similarly, BC is equal to 3 minus 2 whole square plus 1 minus 2 whole square. We are applying distance formula, x1 minus x2 whole square plus y1 minus y2 whole square for the given points. Now 3 minus 2 is 1, 1 square is 1, 1 minus 2 is -1, square is 1, so 1 plus 1 is root 2. Alright, then let's check CD. Now CD would be in that order 2 minus -2, so 2 plus 2 whole square plus 2 minus 1 whole square. Now 2 plus 2 is 4, 4 square is 16, 2 minus 1 is 1, so 1 square is 1, so it is root 17. Alright, and if you calculate AD, AD would be equal to square root of -1 minus -2, so it is -1 plus 2 whole square plus 0 minus 1 whole square. Now -1 plus 2 is 1, 1 square is 1, 0 minus 1 is -1, -1 square is 1, so it is root 2, right? So we can see that the opposite sides are equal, so it may be a parallelogram or a rectangle. To clarify that, we need to check the length of diagonals. Now what is the diagonal? AC is one diagonal, so AC is equal to square root of -1 minus 2 whole square plus 0 minus 2 whole square. Alright, so it will be equal to root of -1 minus 2 is -3, -3 square is 9, 0 minus 2 is -2, -2 square is 4, so it is root of 13, and BD is the other diagonal, so length of BD would be equal to 3 minus -2, so it is 3 plus 2 whole square plus 1 minus 1 whole square, so it is 0. So 3 plus 2 is 5, so it is simply root 25, that is 5 itself, right? So diagonals are not equal, right? So opposite sides are equal, diagonals are not equal, so it is not a rectangle, because for rectangle diagonals must have been equal. So the answer is parallelogram, right? But because rectangle is a subset of parallelogram, we had to check the lengths also. Alright, so the answer is parallelogram, that is B option. Now let's take the fourth question. Fourth question, it has 3 points. Let's take them in the form of a triangle and then we'll check. Let's say A point is 3A 0, B point is 0 3B, and C point is A 2B. Alright, so we can calculate the lengths AB would be equal to square root of 3A minus 0, x1 minus x2, so 3A minus 0 whole square, plus 0 minus 3B whole square. Right, so it is equal to square root of 3A minus 0 is 3A, whole square is 9A square. Now 0 minus 3B is minus 3B, square will be 9B square. So 9 comes out and square root of 9 is 3, so it is 3 root of A square plus B square. Similarly, if I have to calculate AC, it will be square root of 3A minus A whole square plus 0 minus 2B whole square. Alright, now 3A minus A is 2A, 2A square is 4A square, plus minus 2B square is plus 4B square. So 4 comes out and square root of 4 is 2, 2 times root of A square plus B square. And similarly we can calculate BC. BC would be equal to square root of 0 minus A square plus 3B minus 2B whole square. Alright, so it is equal to root of A square plus B square. Right, very clearly we can see that AC plus BC is equal to 2 times root of A square plus B square, which is plus root of A square plus B square, and that comes out to be 3 times root of A square plus B square, and that is equal to AB. So AC plus BC is AB. That means they cannot form a triangle, right? They are not form a triangle. They are collinear points. They form a straight line. It is only possible if it is like this, AC and BC. So A and B here and C here. So this is possible. AC plus BC equal to AB is possible only if they form a straight line. So answer of this question is straight line. Right? For this to be a triangle, AC plus BC should have been greater than AB. Alright? And if it is equal to AB, then it has to be a straight line. They are collinear points. Okay. Now let's take up the next question, question number 5. Question number 5 says points A minus 1 4, B 5 2 are the vertices of the triangle which C 0 minus 3 is centroid. Okay. So let's take it like this. A is minus 1 4, B coordinates are 5 and 2, and let's take another point B and coordinates are alpha beta, and centroid is C given as 0 and minus 3. We already know that the centroid coordinates are calculated as x1 plus x2 plus x3 divided by 3 and y1 plus y2 plus y3 divided by 3. Alright, here centroid coordinates are given as 0 minus 3. So 0 minus 3 should be same as x1 plus x2 plus x3 will be minus 1 plus 5 plus alpha by 3, comma 4 plus 2 plus beta by 3. So if you equate the x coordinates on both sides, you will get 0 equal to minus 1 plus 5 plus alpha by 3, and minus 3 would be equal to 4 plus 2 plus beta by 3. So from here we can calculate alpha and beta, right? So we have 0 equal to minus 1 plus 5 is 4 plus alpha. So alpha is equal to minus 4. Similarly, the other side, minus 3 into 3 will be minus 9 is equal to 4 plus 2 is 6 plus beta. So beta is equal to minus 9 minus 6, that is minus 15. Okay. So that means the coordinates of the third point D, alpha, beta are D minus 4 and minus 15. So x coordinate is minus 4 and y coordinate is minus 15. Alright. Now the next question, question number 6, it says the acute angle between the lines with slopes 3 by 4 and 1 by 7. So let's say the slopes are m1 that is 3 by 4, and m2 that is 1 by 7, right? So the angle between them, suppose the angle between them is theta, then the formula is tan theta equal to m1 minus m2 divided by 1 plus m1 into m2. This is the formula. And for acute angle, we have to take the positive value. So we take tan theta equal to 3 by 4 minus 1 by 7 whole divided by 1 plus 3 by 4 into 1 by 7. If you simplify, tan theta would be equal to LCM of numerator would be 4 into 7, that is 28, and 3 would be 21, and 7 would become 4. So 21 minus 4 upon 28 equal to 1 plus 3 upon 28, right? So 28 gets cancelled, and we will have 21 minus 4 is 17 upon 28, and in denominator we will have 28 plus 3, that is 31 upon 28. Right, so it is 31 upon 28. Alright, so 28 and 28 get cancelled, and we will have tan theta is equal to 17 upon 31. Okay, so that means the value of angle theta is tan inverse 17 upon 31, or that value of theta for which tan is 17 upon 31. Right, so in this case, if you look at the options, none of these seems to be the correct answer, because tan 60 degree is root 3, that does not match. Tan 45 degree is 1, that does not match. And tan 30 degree is 1 by root 3, that also does not match. Alright, now the next question, question number 7. It says the equation of a straight line whose inclination is 60 degree and y-intercept is minus 2. Now, so theta in this case is given as 60 degree, and y-intercept, now y-intercept is minus 2, so that means c is equal to minus 2. So the slope of the line, that is m, can be calculated as tan theta, that is tan 60 degree, which is root 3, and the equation is given as, so required equation of the line is given as y equal to mx plus c. So here m value is root 3 into x plus c value is minus 2. So the answer of the question would be root 3x minus 2, right? This is the answer. Okay, now let's take the next question, question number 8. It says the equation of straight line passing through 6 minus 3 and 4 minus 3 is. Now 8th question, we know the formula for equation of line for 2 points is y minus y1 upon y1 minus y2 is equal to x minus x1 upon x1 minus x2. So here what we have is, now here y1 and y2 are same, so let me write it this way, y minus y1 equal to y1 minus y2 into x minus x1 upon x1 minus x2. Now what is the benefit of this? Let's see. Y minus y1 is minus 3. Now y1 is minus 3 minus y2 is also minus 3. So this becomes 0 multiplied by x minus x1 is 6 upon x1 minus x2 is 6 minus 4. But it doesn't matter because this part becomes 0. So it is y plus 3 equal to 0. So the equation of the line is y equal to minus 3 or y plus 3 equal to 0. So as you can see in the options, y plus 3 is equal to 0. Or if you just take the proper look at the points, it is 6 and minus 3 is the first point, 4 and minus 3 is the second point. In both the points, y coordinates are same. So straight away you can say the equation of the line is y equal to minus 3. Whenever this happens, if there are 2 points given and the equation of the line is asked, and either x coordinate is same or the y coordinate is same, that becomes the equation of line. So here y coordinates are same, so it is y equal to minus 3. If the x coordinates were same, let's say 6, the equation would have been x equal to 6, right? So in this case, straight away we can say, because both the points have same y coordinate, the equation of the line will be given as y equal to minus 3. Now let's take up the next question, question number 9. It says the equation of the image of the line x plus 2 equal to 0. So first of all, x plus 2 equal to 0 means x equal to minus 2, right? And the other line that we have is the mirror that we have is x equal to 0. We have to find with respect to x equal to 0. So mirror is x equal to 0, object is x equal to minus 2. First, let's draw x-axis and y-axis and calibrate it. This position is x equal to 0. Let's say this position is x equal to 1. Let's say this position is x equal to 2. Go on the negative side, it is x equal to minus 1 here and x equal to minus 2 here. Now x equal to minus 2 would mean this line. So this line that I am drawing here, the dotted line, is x equal to minus 2. Now this is our object. Okay. Now x equal to 0 is the mirror. So using the concept of plane mirror, this is the mirror, this is the object. So the image will be formed behind the mirror. That means on this side. And the distance between the object and mirror is 2 units. So the distance between the mirror and image should also be 2 units. So the image will be formed at x equal to 2. Alright. So this is our image. So as the question says image equation is x equal to 2. Hence x minus 2 equal to 0 is the required equation of the image. Right. That is none of these as I can see in the options. Okay. Now let's take question number 10. It says the points 4, minus 5, 1, 1 and minus 2, 7 are. So 3 points are 4, minus 5, 1, 1 and minus 2, 7. As you can see in the options, it says collinear, non-collinear vertices of a triangle, right? So they are either collinear or non-collinear. Now when they are non-collinear, there must be vertices of triangle, and then there is another option, none of these. So first let's do one thing, check the collinearity. Now the condition for collinearity, if you remember, condition for collinearity is area should be equal to 0. Collinearity is area should be equal to 0. So area of the triangle should be equal to 0. And the formula of area is 1 by 2 into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. That should be equal to 0. So we have half into. Now x1 is 4, y2 is 1, y3 is 7. So 4 into 1 minus 7 plus x2 is 1, y3 is 7 and y1 is minus 5. So 7 minus minus 5 will become 7 plus 5 plus x3 is minus 2 into y1 minus y2, that is minus 5 minus 1. This should be equal to 0. Now let's check whether it is correct or not. Now 1 by 2 goes to the other side, becomes 0. Now inside we have 4 into minus 6 plus 1 into 12 plus minus 2 into minus 6. Is it equal to 0? Let's check. 4 into minus 6 is minus 24 plus 12 plus minus 2 into minus 6 is again 12. Is it 0? So minus 24 plus 24, it is 0 equal to 0. That means this is correct, right? So the points are collinear, right? So if the area becomes equal to 0, then we say that the points are collinear, right? So the answer of this question is collinear points. All right. Now the next question, question number 11, it says find the intercepts made by the line 2x minus 3y plus 6 equal to 0 with the coordinate axis. Now first we need to understand the meaning of intercept. Any line looks like this. So whatever distance from origin on x-axis it cuts, it is called x-intercept, and whatever distance on y-axis it cuts, it is called y-intercept. So basically we need to find the x coordinate of this point, that is point of intersection with x-axis, and y coordinate of this point, that is the point of intersection of y-axis. And to do that, we just put x equal to 0 and y equal to 0. That will give us x-intercept and y-intercept, right? So the equation of the line is 2x minus 3y plus 6 equal to 0. I'll repeat the process again. To find the length of x-intercept, put y equal to 0. So if I put y equal to 0, I'll get 2x minus 0 plus 6 equal to 0. So 2x equal to minus 6, x equal to minus 3. This x value is x-intercept. So this is x-intercept. Similarly, suppose we have to calculate y-intercept. For that, put x equal to 0. So if you put x equal to 0 in the equation, you will get 0 minus 3y plus 6 equal to 0. So it becomes 3y to the other side. So 3y equal to 6. So y equal to 2. This y value is equal to y-intercept. So the question is asking x-intercept and y-intercept. That means the lengths are minus 3, that is x-intercept, and plus 2, that is y-intercept. Right? So these are the lengths of intercepts. That is option B, I suppose. Now let's take up question number 12. The question says the equation of the line whose intercepts on the axis are 4 and 3. There's a direct formula. X upon A plus y upon b is equal to 1. This is the equation of the line having A as x-intercept and B as y-intercept. In this question it is given that we'll assume the first one to be x-intercept, so A is equal to 4, and second one to be y-intercept, so B is equal to 3. Just put it in the formula, you'll get x upon 4 plus y upon 3 equal to 1. LCM 12, so we will have 3x plus 4y equal to 1. Divide by 12 equal to 1. So it is 3x plus 4y equal to 12. This is the required equation of line. That is option B. Okay. Now the next question, question number 13, it says find the equation of line which cuts off equal and positive intercepts. So let's assume that x-intercept is equal to y-intercept is equal to A, right? And both are positive intercepts. That means the equation of the line can be written as, no, there is another thing. It says the sum of those intercepts is 12. So A plus A is equal to 12. So we have 2A is equal to 12, that is A equal to 6. So we have calculated the length of x-intercept as well as y-intercept. Now equation of the line can be written as straight away x upon A plus y upon A is equal to 1 because both the intercepts are A. Now A is equal to 6, so it is x upon 6 plus y upon 6 is equal to 1. LCM 6, so it is x plus y upon 6 equal to 1. So x plus y equal to 6 is the required equation. Okay. Now let's take question number 14. It says the equation of the line passing through 1, 2 and parallel to 3x plus 4y plus 7 equal to 0. Now whenever we have to take equation of line parallel to a given equation, what do? We straight away start from the given equation. Here the given equation is 3x plus 4y plus 7 equal to 0. So let's assume that let the equation be, we'll assume the equation to be 3x plus 4y plus k equal to 0. So always remember, for parallel lines the coefficients of x and y must remain same, the constant must change. So let's say the new constant is k. Now we know that this line passes through, in the question it is given, it passes through 1, 2, the point 1, 2. So put the coordinates of 1 and 2 in place of x and y in this equation, find the value of k. So if you put x equal to 1 and y equal to 2, you will get 3 into 1 plus 4 into 2 plus k equal to 0, right? See, if any line passes through a point, that means that equation of the line must be satisfied by that coordinates of the points, right? So we have 3 plus 8 plus k equal to 0. That means k is equal to minus 11. So the required equation, so we have found the value of k. So the required equation is 3x plus 4y plus k, and in place of k it is minus 11. That is equal to 0. So you can say 3x plus 4y equal to 11 is the required equation of this line. Okay. The next question is on the similar lines. It says equation of straight line parallel to ax plus by plus c equal to 0. So the parallel line equation must be ax plus by plus k equal to 0, and it passes through origin, so it must pass through 0, 0. Origin coordinates are 0, 0. Put 0, 0 in this equation, you will get a into 0 plus b into 0 plus k into 0. So it becomes k equal to 0. So if you put k equal to 0 in this equation, you will get ax plus by plus 0 equal to 0. So the required equation is straight away ax plus by equal to 0. Right? This is the working method. Now let's take question number 16. What does it say? It says the equation of a straight line passing through 1, 2 and perpendicular to the line 3x plus 4y equal to 7. Now the given equation is 3x plus 4y equal to 7. So straight away we can assume the perpendicular line to be, I hope you remember, to find the perpendicular line you exchange the coefficients of x and y. So 3x and 4y are the original coefficients, so it becomes 4x and 3y, and then change the sign of any one of them. So what we'll do, we'll keep x as positive and y was earlier positive, so make it negative. I repeat, to find the perpendicular line, exchange the coefficients of x and y and then change the sign of any one of them. We usually change the sign of y. So that it will be 4x minus 3y plus a new constant k equal to 0. This is the line perpendicular. Alright. Now it passes through, this line passes through a given point 1, 2. Okay, so passes through 1, 2. The coordinates of the given point are 1 and 2. So put x equal to 1 and y equal to 2 in the given equation. So it will be 4 into 1 minus 3 into 2 plus k equal to 0. So it is 4 minus 6 plus k equal to 0. So gives us k equal to 2. Alright. Put k in the equation, you will get the required equation to be 4x minus 3y plus 2 equal to 0. So I think the first option seems to be the correct answer. Alright. Now the next question, question number 17, is the easiest of the exercise. It says find the point of intersection of the lines x plus y plus 1 equal to 0 and 2x minus y plus 5 equal to 0. Always remember, to find the point of intersection of two lines, the only thing that you need to do is solve their equations. Right? So here we have two equations. Let's try and solve. Add them. So if you add them, y gets cancelled and we will have x plus 2x, that is 3x, plus 1 plus 5 is 6 equal to 0. So 3x plus 6 equal to 0. So 3x is equal to minus 6. 3x is equal to minus 6, x equal to minus 2. Let's put x equal to minus 2 in the first equation. First equation is x plus y plus 1 equal to 0. Put x equal to minus 2 plus y plus 1 equal to 0. So from here you get y equal to 2 minus 1, that is 1. So the required point of intersection is equal to minus 2, 1. That is the coordinate of the point of intersection. Minus 2, 1. Alright, that is B option. Okay. Now the next question, question number 18. Question number 18. It says the equation of the line passing through the points of intersection of the lines 5x minus 2y equal to 3 and 4x minus 7y plus 3 equal to 0. So the only thing that the simplest thing that you can do is solve these two equations and find the point of intersection. Let's solve them, right? Let's multiply the first equation by 5 and take everything on the same side. So first equation is 5x minus 2y minus 3 equal to 0. 5x minus 2y minus 3 equal to 0. And the second equation is 4x minus 7y plus 3 equal to 0. So let's multiply the first equation by 4 and the second equation by 5. So you get 20x minus 8y minus 12 is equal to 0. Now second equation will become 20x minus 35y plus 15 is equal to 0. So if you subtract, this becomes minus, this becomes plus, this becomes minus. So 20x and 20x are cancelled. Minus 8y plus 35y will be 27y, and minus 12 minus 15 will become minus 27 equal to 0. So it becomes y equal to 1. If you put y equal to 1 in any one of the equation, let's put it in the first one. So it is 5x minus 2y minus 3 equal to 0. Put y equal to 1, you will get 5x minus 2 into 1 minus 3 equal to 0. So this gives us 5x minus 2 minus 3, that is equal to 5. So this gives us x equal to 1. So the point of intersection is, equal to 1, 1. So now the question becomes, we have to find the equation of the line that passes through 1, 1 and is parallel to 3x minus 2y plus 5, right? So let's continue the question number 18, right? So the equation of the line that is parallel to 3x minus 2y plus 5 equal to 0. So the line parallel to this equation would be 3x minus 2y plus k equal to 0, right? And it passes through the previous point of intersection that we had calculated was x equal to 1 and y equal to 1, right? So it passes through 1, 1. So if you put 1, 1 in place of x and y, you will get 3 into 1 minus 2 into 1 plus k equal to 0. Now 3 minus 2 is 1 plus k equal to 0. So k is equal to minus 1. So what we did, first we calculated the point of intersection of the first two lines, that is 1, 1. And now we have to find the line parallel to 3x minus 2y plus 5 equal to 0 passing through 1, 1. So we got the value of k as minus 1. So our required equation will be 3x minus 2y plus k, in place of k minus 1 equal to 0. So it is 3x minus 2y equal to 1. This is the required equation. Okay. Alright, so this is the simplest way of doing this question. Now let's take up question number 19. It says the equation of the line passing through the point of intersection of lines x plus y plus 1 equal to 0 and 2x minus y plus 5 equal to 0 and through the point 5 minus 2. I think the simplest way would be to solve the first two equations, that is x plus y plus 1 equal to 0 and 2x minus y plus 5 equal to 0. If you simply add, y gets cancelled and we get x plus 2x, that is 3x, plus 5 plus 1, that is 6 equal to 0. So x is equal to minus 2. If you put x equal to minus 2 in the first equation, it will be minus 2 plus y plus 1 equal to 0, and that will give us y is equal to 1. So our first point is minus 2, 1, and the second point given as 5 minus 2. Alright. So we have to find the equation of the line passing through these 2 points. So we'll apply the formula y minus y1 upon y1 minus y2 equal to x minus x1 upon x1 minus x2. Right? Now y minus y1, so it is y minus 1 upon y1 is 1 minus y2, so 1 minus minus 2. Alright. Now x minus x1, x1 itself is minus 2 upon x1 minus x2, so it is minus 2 minus 5. So if you simplify, you get y minus 1 upon 3 equal to x plus 2 upon minus 7. So cross multiply carefully, you will get minus 7y plus 7 equal to 3x plus 6. Take 7y to the other side and 6 to this side. So 7 minus 6 is equal to 3x plus 7y. So the required equation is 3x plus 7y is equal to 1. Right? Or 3x plus 7y minus 1 equal to 0. In the options it is given 3x plus 7y equal to 1. Now question number 20. It says the equation of the line parallel to 3x minus 2y plus 1 equal to 0. So parallel line would be straight away equal to 3x minus 2y plus k equal to 0. Right? And this line passes through origin, right? So passes through the origin coordinates are 0, 0. So put 0, 0, you get 3 into 0 minus 2 into 0 plus k equal to 0. So k is equal to 0. If you put k equal to 0, the required equation becomes 3x minus 2y plus 0 equal to 0. Hence it is simply 3x minus 2y equal to 0. That's the answer of this question.